Okay, good morning, everybody. Today we're going to be talking about some more properties of logarithms. I think I had suggested in days past where I was lecturing that you should probably get a note card and write all these properties down. It's a good idea to have them all in one place instead of having to flip back and forth through your notebook. So I'm going to give you a few more properties today. So let's get started. The first thing that I'm going to show you are these three logarithmic properties. They're not really three, they're really one, but they deal with three different scenarios, and that is the change of base. So if you notice on your calculator, the only two logs that you can evaluate directly with the log button on your calculator is log, which is log base 10 when there's no base listed, and then natural log, which is just log base e. So there are other bases, and as we progress through and learn more about logs, you'll understand why there's different bases. But in the meantime, we need to have a way to be able to evaluate a log if the base is different than base 10 or base E, because that's the only two buttons we have on our calculator. Now, there's a couple ways to do that on a calculator especially before the having the fancy graphing calculators. And if you only had a scientific calculator, this would be what you would need to use, which is called the change of base formula. And there's three different scenarios here. The first one shows you how to actually, I'm going to skip the first one for a second. Let's look at the second one. The second one says base 10. And this one says if you have log base a of x, you can evaluate that simply by taking log of x and then dividing it by log of a. Notice the logs that are in the fraction are both base 10. So we took it from base a and changed it into base 10 and divided them, and you get the solution to the original problem. Now, this formula, this change of base formula, works not only to change it into base 10. If you look in the first one, you can change it into a different base. You can see they changed it into b, but b can be any number you want. The last one here, base e, is saying if you have log base a of x, you actually use natural log of x and divide it by natural log of a, and you will get the solution to what log base a of x is. This might seem a little bit confusing. Hopefully it'll make more sense whenever we do an actual problem. All right, so one way to look at the change of base formula is that the logarithms with base A are constant multiples of logarithms with base B. The constant multiplier is 1 over log base B of A. And to be honest with you, I think that's just more confusing. So let's try an actual problem. So here's example one. We have log base 4 of 25. And to evaluate that on a calculator, you'd simply take log of 25 and you would divide it by log of 4. And when you would do that, log of 25 is 1.39794 rounded to the fifth decimal place, and log of 4 is 0.60206. And so those two divided together will give you 2.3219. Again, that's using the change of base to move it from base 4 to base 10 so we can evaluate it on our calculator. Here's another example. This is log base 4 of 25. Log base 4 of 25 is can also be evaluated using the natural log. So in the first example A, we used log base 10. There's no base written, so it's base 10 to find that it was 2.3219. You can also take natural log of 25 and divide by natural log of 4, and you will get the exact same answer. Now, the numbers that you come up with here and here aren't the same, but the answer at the end will be the same. You can see it's 2.3219, and if you go back to the one before that, that was also 2.3219. So it doesn't matter what log you change it to the base of. Now, in the example 1a, the reason why we changed it to base 10 is because we have a base 10 button on our calculator. Same with 1b. We have a natural log button on our calculator. So those are the two bases that it is easiest to change it into. Now, we have some more properties of logarithms that I want to share with you now. I'm not going to pause for a long time. If you're actually taking any physical notes, you can pause the video. But I'm going to go through these and then I'm going to show you how they all work. So the first one's called the product property. And what the product property does is it allows us to break up a log of a product. So here you can see we have log base A of u times v. And what you can do with this product, U times V, is you can actually log each of the pieces of the product individually. So you can take the log of U and then you simply add it to the log of V. That property also holds true for the natural log, which is just log base e. So it's not really anything different than log. The quotient property. So up here, this was a product property. When they're multiplied, you can split them and add them. When they're being divided, when you're logging a quotient, you can split them and separate them with a minus. And the last property we're going to talk about today is the power property. This one is really important. We use this one a lot coming up. So if you notice, this is log base A of u to the nth power. And what this allows us to do, anytime you log something, a base with a power, it allows you to take this power n and bring it down in front of the log like this. So you can see nothing else changed other than bringing that n from being a power on u out in front, and now it's multiplying the log. So now let me show you a couple examples of this. So these aren't really simplifying any more than what you see. This is just using these properties that I just showed you to write each logarithm in terms of natural log of 2 and natural log of 3. So looking at natural log of 6, and the hint here is 2 and 3, we can break 6 up into natural log of 2 times 3. So we rewrote 6 as 2 times 3. Now, this is where our product property, I'm going to flip back for a second. Our product property would come into play here. We are logging, or in this case, natural logging, two numbers that are multiplying each other together. So what that allows us to do is to log each of the numbers separately and then separate the two logs with a plus sign. So you can see it becomes natural log of 2 plus natural log of 3. The next one is a quotient. And as I showed you in the previous slide with the quotient property, if you are logging a quotient, you can log the numerator and you can log the denominator separately and then separate them with a minus. Now, we are not quite done because in the directions it says write each logarithm in terms of natural log of 2 and natural log of 3. You can see here this natural log of 2, that's fine. But the natural log of 27, that doesn't fit into this quite yet. But what you have to recognize is 27 is actually a power of 3. 27 is 3 to the third power. Now that we have it written as natural log of 2 minus the natural log of 3 to the third, the last property, the power property, allows us to take this power 3 and move it out in front of the natural log. And so we're going to do that. And now we have an expression that is written in terms of natural log of 2 and natural log of 3. And as I said, these were more exercises in using the formulas, or I'm sorry, the properties of logs, not really trying to get a one single numeric answer. The next one is going to ask you to find the exact value. So this is example 3a, and it says find the exact value of log base 5 of the cube root of 5 without using a calculator. Now this is a key thing, without using a calculator, because when you anytime you have a problem that says without using a calculator, they are telling you that you need to use your log properties in order to solve this. So one of the tricks to logarithms is anytime you see a square root, cube root, fourth root, fifth root, doesn't matter, whatever kind of root, you should rewrite the root so it is an exponent. So therefore, the cube root gets rewritten as the 1/3 power. Hopefully you remember that. If you remember, the square root's the 1/2 power, cube root's the 1/3 power, the fourth root is the 1/4 power, and so on. So you can see we have log base 5 of 5 to the 1/3 power. The next thing to remember is The power property allows us to bring this 1/3 out in front of the log and then multiply the log. And then the last property is a property we have already previously discussed, which is when you have a log with a base that matches the number that's being logged, in this case, log base 5 of 5, that turns into 1. So you're left with 1/3 times 1, which is 1/3. So the answer of log base 5 of the cube root of 5 would be 1/3. This problem goes along with the last one. They want you to find the exact value without using a calculator. So kind of the same thing. Keep in mind natural log, the base of natural log is e. So you can see this is just log base e of e to the sixth. This is natural log, which is just log base e of e to the second. So the first thing we're going to do is we're going to use the power property to bring the sixes down, the 6 and the 2 down in front of the natural logs. And then you can see we have natural log of e, which hopefully you remember that's log base e of e, which just turns into 1. So you're left with 6 times 1 minus 2 times 1, which becomes 6 minus 2, which is 4. All right, guys, that's it for the lecture for today. Hopefully those properties made sense to you all, and I hope you're all doing well, and I'll talk to you soon.